Welcome to qnawire.
Hello there. Today we're going to be looking at this problem where we have a pion decaying into a positive muon and a neutrino and a photon. So essentially we're going to assume that the neutrino has zero rest mass as the problem is stated, and then we will just solve this algebraically. So let's write down the system here. Okay, so I have a positive pion that decays into a positive muon plus a neutrino plus some sort of energy. And I'll just assume that this is going to be a gamma photon, so I wrote gamma as a subscript. Okay, now what we're going to do is we're going to assume that this has zero rest mass. So although it's good to write it down in this problem, the way we're going to solve it, it doesn't matter. And I'm going to get that for this energy, 270 times the mass of an electron. All right, this is our pion. This is rest mass times c squared. So now it's in terms of energy, is equal to the muon, which is 207 times rest mass of electron times c squared. That's the muon, plus excess energy completes the reaction. And so algebraically, we can just solve it this way. The photon is going to be the difference in these, so 270 minus 207 mass of the electron times c squared is going to give us the energy. Now what do we need? We need to know what the mass of the electron is. Mass of an electron, rest mass, is 0.511 MeV per c squared. And notice how c squared, it's going to cancel here. So what we're going to be left with is that's equal to 63 times 0.511 MeV per c squared times c squared. They're going to cancel, and that leaves us with an energy of 32 million electron volts, or 32 times 10 to the 6 electron volts. Big M is mega. That means times 10 to the 6. Okay, so this is the answer to the first part. Now the second part asks, why can't we go the other way? Why can't a positive muon decay into a positive pion? The simple explanation for this is energy conservation. I have 270 here, all right? And this 270, there's more energy here. I can't start with less energy and create energy from nothing. That'd violate the conservation of energy principle. So that's really the reason. The pion has more rest energy than a positive muon. All right, thanks.